Today we're going to look at how we write a number as a product of its prime factors. But just before we get into the examples, I'm just going to cover some basic terminology and explain what exactly these words mean when we talk about them in maths. So factors, multiples and primes. So the difference between what a factor and a multiple is and what of course a prime number is. So a factor of a number divides into it, leaving no remainder. So for example, if we would look at the number 6, the factors of 6 are 1, 2, 3 and 6. So 1, 2, 3 and indeed 6 itself, they all divide into 6, leaving no remainder. Sometimes people would confuse factors and multiples. The difference of a multiple is part of a number's times tables, and that's how I would always try to remember to think of the word multiply times tables. So multiples of 6 are 6, 12, 18, 24, 30 and so on. So multiples of a number go on forever and ever. A number will have an infinite number of multiples, but it'll only have a finite number of factors. So for example, again, using the number 6 as our example, 6 has 4 factors, 1, 2, 3 and 6. They're the only 4 numbers that will divide into 6, leaving no remainder. However, its multiples, like any number, will go on forever. So 6, 12, 18, 24, 30, 36 and so on. If I was to ask you a multiple of 6, you could say 600, 6,000, 6 million and so on and so forth. Okay. A prime number is defined as a number that can only be divided by itself and 1. So these are our first set of prime numbers. The smallest prime number we have is 2, and it's also a special prime number because it's the only even prime. So it fits the description of a prime number because the only thing 2 can be divided by is itself and 1. So the only thing that will divide into 2 is 1 or 2. 3, 5, 7 and so on, these numbers, the only thing they can be divided by is either 1 or themselves. 11, 13, 17, 19 and again they go on, but we'll stick with these early primes for now. We need to know this for tackling these types of questions where we're asked to find a number as a product of its prime factors. Okay, so say you're doing your GCSE Maths exam and you come across a question just like this, and it'll very simply state find 216 as a product of its prime factors, or write 216 as a product of its prime factors. That sounds like a very long, confusing mathematical sentence, but when you know how to tackle the question, it's not overly difficult. These are the 3 steps that we're going to use to tackle the question. We're going to start dividing using the smallest possible prime. So we're asked to find its prime factors essentially, so factors of 216, but we're only going to find and use prime factors, and that's why we're going to start off using the smallest possible prime. So when you're asked to tackle this type of question and it's an even number, well, any even number can always be divided by 2, and as we'll see here, 2 is a prime number. So I use what's called a division ladder, and there's another way of doing this division which I'll show you also. It doesn't really matter what way you've been shown it in school or what way you prefer. You use whatever method is preferable to yourself. So I'm going to take 216, I'm going to divide down the way like this, and this is why it's called a division ladder. So 216 divided by 2, 2 is our prime factor. Now, if you're doing the M1, 2, 3 or 4 exam, you'll of course have a calculator, and you can always just check if the prime number will go into it very easily. 216 divided by 2, of course I know that will divide. 2 into 2 goes once, 2 doesn't go, 216, 8 times. But of course you'll have a calculator, so you'll not have to work that out the way I just did. That's always handy to be able to, because when you come to doing M5, 6, 7 or 8, there is a non-calculator aspect of the exam. So if you are practicing these, it may be a bit of practice with your division to do it without a calculator. 2 into 108 gives me 54. So I can keep using 2 until I can't use it anymore, as in we come across an odd number. 54 again can be divided by 2. 2 into 5 goes twice, carry the 1, that's now 14. 2 into 14 goes 7 times. So I've used 2 3 times here, and now I'm down as far as 27. The second step is just to keep this in mind, keep dividing until we reach 1. We're down to 27. I can't use 2 on this anymore. The next prime number up from 2 is 3. Well, from having a good knowledge of our times tables, we know that 3 does in fact go into 27. 27 is part of our 3 times tables. So 3 into 27 goes 9 times. 3 can again be used because 9 is of course part of our 3 times tables. Okay, so 3 into 9 goes 3 times, and when we get to this point, the only thing we can divide 3 by to get 1 is of course 3 itself, because 3 is a prime. So the only thing we can divide 3 by here to get ourselves down to 1 is 3. 3 into 3 goes once. Okay, now where we get our final answer from is these numbers down the side of the ladder. Okay, so product in maths, the word product in maths means multiply, so 216 as a product of its prime factors, as in if I was to multiply all these numbers down the side, 2 times 2 times 2 times 3 times 3 times 3, I would get back to 216. So we'll write this out. This is in fact our answer. Okay, so these numbers multiplied down the side is our answer. Now I've added this third step in here, and what you'll find is more often than not within our GCSE Maths exam, they will ask you to leave your answer in what's known as index form. Index form is just a way of shortening something like this. So if I have 2 times 2 times 2, well, we can use an indice to shorten that. 2 times 2 times 2, multiplying 2 by itself 3 times is indeed 2 cubed. And similarly, 3 times 3 times 3 is 3 cubed. So that is now my final answer, particularly if I've been asked to leave it in index form. And that is important, because if you're sitting in the exam and you're asked to leave the answer in index form and you unfortunately just leave it in this format here, you will lose a mark. So keep an eye out for that. In my opinion, it's best to leave it in index form anyway, as best practice, unless of course you're specified to do otherwise. Now, the other wee way of working this out, okay, it's the same thing, we are dividing, it's just a different way of showing you're working out. And some of you might have been shown this in school. So it's a factor tree. So what I mean by that there is I look at our number 216 and I think of a pair of factors that go into 216. And when I say a pair of factors, these two factors must multiply together to give me 216. So not familiar with my times tables up to 216. I know that 2 will go into it, 2 and 108. So 2 times 108 would give me 216. That's why they are a pair of factors. And I split them up like this. And what I do, as I split the numbers up, I circle the primes. Okay? So now I have to split 108 up because I know 108 is not prime. So 108 splits into 2 and 54. So they are a pair of factors for 108. I can circle 2 because it's prime. So 54, I could split that up into, and again, just to change things up again, if I was looking at it, I go, well, 54 is part of my 6 times tables. So 6 nines are 54, so 6 and 9. When this happens, I'll have to split both these up. So 6, I can split that up into 2 prime factors, 2 and 3. So I've gone as far as I can go with this branch of the tree. And then 9 can only be split up into 3 and 3. Okay? And the reason I don't look down this is because sometimes people make a mistake of using 1 and 6. Well, that would be pointless because 1 isn't prime and you just end up splitting 6 up again into 2 and 3. Okay? But when you do it this way, you end up with the same prime factor. So I've got 1, 2, 3 2s, 1, 2, 3 3s. So same again, 2 cubed times 3 cubed. So either way you do it, using a factor tree or a division ladder, gives you the same answer at the end. So just to give us a wee bit more practice, we'll try this question. Okay, so write 297 as a product of its prime factors. And we're going to assume we've been asked to leave our answer in index form in this case as well. So I'm going to use my preferred method, which is the division ladder. Now 287 is an odd number, so I can't start off using 2. So I'm going to use 3. Now if you're looking at that and thinking, well, how do you know does 3 go into 287? Certainly nobody knows there are 3 times tables up to 287. First off, again, just to remind you, in your M1, 2, 3 or 4 exam, you will have a calculator just to check that. Another wee helpful tip just to give you is that, see if you look at a number and add its digits together, if the 3 digits add to a multiple of 3, then it can be divided by 3. So 2 plus 9 plus 7 gives me 18. 18 is part of the 3 times table, so before even dividing that, I know that can be divided by 3. And that works for any 3 times table. So take 27 for example. I mean, I do know 3 nines is 27, but if you're looking at 27 and doubting yourself for a second, can it be divided by 3? Look at its digits. 2 plus 7 is 9. 9 is part of the 3 times tables, so 27 can in fact be divided by 3. Okay, don't need to know that, it's just a helpful tip for testing if a number can be divided by 3. Anyway, doing this without a calculator, of course you can do it with a calculator in your 1, 2, 3 or 4 exam. 3 into 2 doesn't go, carry the 2, 3 into 29 goes 9 times with 2 left over. 3 into 27 again goes 9 times, so now I have 99. 99 can again be divided by 3. 3 into 99 gives me 33. I can again divide by 3. 3 into 33 gives me 11. Now, looking at 11 going, well, what prime number goes into 11? Just the importance of being familiar with your early prime numbers as well. 11 is in fact a prime number. So the only thing we can divide 11 by to give us 1 is 11 itself. So I have to divide by 11 here. So 11 divided by 11 is 1. This, in terms of its answer, is 3 times 3 times 3 times 11. So again, assuming I've been asked to shorten this into index form, 3 times 3 times 3 shortens to 3 cubed. The 11 is on its own, so I can't do anything with that, so I just bring that down. So my final answer is 3 cubed times 11. Now, it's important that you get some practice with these types of questions. They are quite easy and straightforward once you know how to do them. And they will help us for what we will do in our next lesson, where we will look at how we find the highest common factor or the lowest common multiple of 2 numbers. Have a go at the questions at the end of the video just to give yourself a bit of practice, and anything at all, just ask in the comments.